also. So I have written here, transaction in relational databases use asset properties, and they are the name, atomicity, consistency, isolation, durability. I am not going to discuss about these properties in detail because I expect that you know. But natural question is why these asset properties require. Okay. So as I told, there are several applications where the requirements of data consistency is more important. So requirement of the applications dealing transactions as a whole one unit of work. Transaction, you may be familiar with the definition. So financial sectors like banking, insurance, asset properties fulfill the requirements of the application. Because of that, these asset properties are necessary. So if transactions are executed serially, one after the other on a single machine, then there is no problem of concurrency control and recovery mechanism. So single transaction, it is shown here. Here in transaction, from point of view of the database, only read and write operations are relevant because the application either read data value from the database or it writes data value in the database. Okay, so when we have to analyze serializability and the concurrency issues, then we take care or we consider only these read-write operations. And the order of read-write operation is maintained such that the consistency could be maintained in concurrent execution of the multiple transactions. So if transactions are executed serially one after the other on a single machine, no concurrency control and recovery mechanism will be required. However, system performance will be poor. But in such scenario, we have poor performance of the system. So to improve the performance, we permit concurrent execution of the transaction. So here it is the scene of there are the 4 transactions and we allow their execution. So here we have to maintain the execution process of each transaction such that the updation made by one transaction and other transaction is also interested to make the update or want to read. So that read-write operation should be such that each transaction is working in isolation. Okay, so that means the transaction being executed concurrently, but their effect is equivalent to the serial execution of the transaction one after the other. So it is called serializability. Okay, so to improve the performance of the system, we allow concurrent execution of the multiple transactions. So here concurrency control mechanism will be required. Okay. So you study in chapter of transaction management, schedule of the transaction. The transactions are executed in so and so schedule. Then the serializability, consistency, or asset properties can be ensured. And in case of failure, we use recovery mechanism. So in the event of failure, we have to recover. So if we want to recover the values of the data items before starting of the execution of the transaction, that means we have to maintain somewhere each and every read-write operation details, okay, somewhere. Only then we can recover earlier state of the database by going through that record. So that kind of record generally they are called log files. Okay, every operation is being carried out, so its information is also maintained there. Database management system have to carry out one more exercise in parallel in the background. Okay, that is the log log file or log table. So here concurrency control mechanism to maintain serializability of scheduling will be required, and in case of failure, recovery mechanism will also be required. Only then the consistency of data in the database can be ensured. So in case of single machine or standalone machine, but what will happen in case of multiple machines or distributed environment? Now we have several machines and all machines are participating in computation. Okay? Computing is also distributed. And my database, what should be the status of the database? Whether it should also be distributed or it should work in client server mode. Okay. In both scenarios, how the consistency can be ensured. So that becomes important. So here I read first. In case of distributed environment or multiple machines, computing will be distributed. Computing will be distributed. That means computing is being carried out on several machines instead of a single machine. Here we have different distributed architecture or style patterns. Now these machines are distributed, but how they are arranged? Okay, what is the architectural? What kind of connectivity they have? Okay, so there can be several possibilities. So they have different architectural patterns. Database will be distributed in master slave or distributed in terms of a part of database is kept on one machine and some kind of replication, or in simple mode you can understand there is one database, and if I say it is distributed, one question will be what is distributed? The whole database is distributed or a part of database is on one machine, another part is another machine. So if I say it is a single database, then what I expect from where I can get my data in lesser time. So several such issues will be there. So what happens here? There is a database. I can say one table is there, and I have to keep this table on all the machine. That means the copy of the table will be on all the machine, or part of the table will be on all several different machines. So in that scenario, we have partitioning, we have horizontal partitioning, vertical partitioning, okay, and replication, how much I should replicate. So several such issues become important there, and I have written here, database will be distributed or master slave. Partitioning, fragmentation, replication, and other issues become important. Consistency will have to be maintained in all copies of the data in all the sites. Suppose one data is updated by user application at one site. The change made in one data value have to be reflected in all the copies of the table in all the sites. So lot of extra work will have to be done here just to maintain consistency of one data value. And updation is also very frequent. Then it takes a lot of computation because network is involved here. So in case of consistency will have to be maintained in all copies of the data on all sites. In case of network breaks, fails or partition into two or more parts, then what about the consistency and availability of data on all sites? And suppose because of several reasons, there may be possibility that a network is failed or network is broken or partitioned or failure. So in that case, what will happen about the consistency? Because communication cannot be made now between the disconnected parts. And what about the availability? Some data that I uh, expect on my site at one node, but the data that is on the site that is not present now, it is in another part of the network that is already broken or divided or partitioned. Okay, so updating same data in multiple copies on different sites will demand more and more overheads. Overhead means extra work, all these. So this is a big problem. Now, what about the database in this new environment and what to do with transactions in case of multiple machines? So here cap theorem or properties come in picture for discussion. Otherwise, everything can be done and there is no need of any such kind of new theorem or properties. So first I read what are these three consistency, availability, and partition. Consistency in distributed databases means that all nodes observe the same data at the same time. Therefore, the operations in one partition of the database should reflect in other related partitions in case of distributed database. Operations which change the sales data from a specific showroom in a table should also reflect in changes in related tables which are using that sales data. Availability means that during the transactions, the field values must be available in all partitions of the database so that each request receives a response on success as well as failure. Failure causes the response to request from the replicate of data. Distributed databases require transparency between one another. Network failure may lead to data unavailability in a certain partition in case of no replication. Replication ensures the availability. Partition means division of a large database into different databases without affecting the operations on them by adopting specified procedures. Now this is the cap theorem. Cap theorem states that it is not possible to guarantee all three of the desirable property: consistency, availability, and partition tolerance. Okay. Partition tolerance here means ability to tolerate the partition. That means if it is if network is divided into parts, even then it should work or it should be available. So at the time, cap theorem states that it is not possible to guarantee all three of the desirable properties: consistency, availability, and partition tolerance. At the same time, in a distributed system, which data distributed system with data replication. If this is the case, then distributed system designer would have to choose two properties out of the three to guarantee. It is generally assumed that in many traditional SQL applications, guaranteeing consistency through ACID properties is important. On the other hand, in a NoSQL distributed stores, a weaker consistency level is often acceptable. And guaranteeing the other two properties, availability, partition tolerance, is important. Hence, weaker consistency levels are often used in NoSQL system instead of guaranteeing serializability. In particular, a form of consistency known as eventual consistency is often adopted in NoSQL system. So instead of using consistency as we have in relational database, here we relax the consistency and we use one new term that is called eventual consistency. Consistency is not just after completion of the transaction is achieved. It will be achieved somewhat later time. Okay, so eventually, ultimately, finally, it will be consistent, but it may be somewhat late. Partition tolerance refers to continuation of operations as a whole, even in case of message loss, node failure, or node not reachable. Brewer's cap consistency, availability, and partition tolerance theorem demonstrates that any distributed system cannot guarantee C, A, and P together. All these three properties cannot be satisfied collectively. Consistency, all nodes observe the same data at the same time. Availability, each request receives a response on success or failure. Partition tolerance, the system continue to operate as a whole even in case of message loss, node failure, or node not reachable. Partition tolerance cannot be overlooked for achieving reliability in a distributed system. Thus, in case of any network failure, a choice can be database must answer, and the answer would be old or wrong data. Database should not answer unless it receives the latest copy of the data. Okay, so we have two options. So here availability and partitioning, and here consistency and partitioning. The cap theorem implies that for a network partition system, the choice of consistency and availability are mutually exclusive. CA means consistency and availability, AP means availability and partition tolerance, and CP means consistency and partition tolerance. Okay. So one can say in short, or another way of understanding cap theorem, the desirable properties of distributed system: consistency, availability, and partition tolerance. All nodes see the same data values at the same time. All requests get an answer. The system keeps functioning in case of network failure. All these should be, but in practice it is not possible, all these three, and we have to make some compromise like situation. And based on relaxing one property, we have several solutions. Okay, so that solution I will show you after reading it. Now here you see consistency in the relational database and consistency in NoSQL database. Both have different meaning. Okay. In the relational database, we get consistency immediately on completion of the transaction processing. But in NoSQL database, we get consistency after a period of time or some later time. So it is important to note here that the use of word consistency in cap and its use in ACID do not refer the same identical concept. In cap, the term consistency refers the consistency of the values in different copies of the same data item in a replicated distributed system. In ACID, it refers to the fact that transaction will not violate the integrity constraint specified on the database schema. However, if we consider that consistency of replicated copies is specified constraint, then the two uses of the term consistency would be related. Here, if you one important thing is that when we say acid properties are satisfied, then we say consistency constraint. One simple example, when we transfer money from one account to another account. Okay. Then what is the consistency here? The values of data should be as per the values after deduction. So how to know whether correct amount is transferred in another account or not? So one rule is identified that sum of the amount of money in both accounts before transfer and sum of the amount in both accounts after completion of the transaction or after transfer operation. So total amount will remain same. If I make this rule and if I also check this rule, that means I am using one more extra feature or ability by which I maintain the data values or I ensure the data values are correct or not. So when you say asset properties consistency, that means you are also taking care of the constraint if it is defined there. Okay, if it is defined there. But in distributed database, consistency only refers that the copy has been replicated. Same value has been, some data is updated at one side. Now the same value have to be replicated on other sides. Only that is sufficient to define the consistency of the data. But here when we say about relational database and it is also using asset properties, that means the constraint is it is also checking. So it will depend whether constraint is specified or not. So we have two terms, strong versus eventual consistency. The consistency we use in relational database, we use the term strong consistency asset properties. All nodes see the same data values at the same time. It in case of distributed. Okay. So one is the strong consistency, other is the eventual consistency. Some nodes may see different data values at the same time, but if we stop injecting updates, the system reaches strong consistency. This is simple diagram. Availability, partition tolerance, okay, consistency not. Okay. So initially some change made at one side in the beginning, consistency will not be there, and after a time it will be consistent. After reconnection of the and resolution of update conflicts, consistency can be. So this is when we make compromise with one condition, then we have these two solutions. And if here you see consistency availability, and if it is a case of a standalone machine, the distributed database scenario, that means we have this solution relational database MySQL, PostgreSQL. So it is SQL relational database. But if we have distributed scenario, then we have to think about whether database is distributed. And if it is distributed, then we have to work a lot for maintaining consistency and replication and partitioning, okay, and then query processing. So all these come in one course that I taught earlier, that is the distributed database. So this is one simplified. So here we are making compromise with consistency. So here we are taking availability and partition tolerance, and here we are considering consistency and partition tolerance, and here availability is compromised. So they are the solutions here. TouchDB, Cassandra, DynamoDB, React, Patchbase, MongoDB, Redis. So because of this new scenario of commodity hardware availability and cloud computing and cheap cost of hardware, this NoSQL databases has become popular, and new applications they have also require solution. So now the new term has been defined, that is base. B stands basic, A availability, basic availability as soft state, and E eventual consistent. That means earlier we have definition of asset. Now new definition has come, that is the base. So in scenario of NoSQL, the transaction and transaction definition will be in terms of this base. So base properties, so B stands for basic availability, S stands for soft state, E stands for eventual consistency. So basic availability ensures by distribution shard. Shard means one we divide data into parts and we keep one copy or multiple copies. Shard many partitions of huge data stored across many data nodes with high degree of replication. Then a segment failure does not necessarily mean a complete data store unavailability. Soft state ensures processing even in presence of inconsistencies, but achieving consistency eventually. A program suitably takes into account the inconsistency found during processing. No SQL database design does not consider the need of consistency all along the processing time. Eventual consistency means consistency requirement in NoSQL databases meeting at some point of failure, some point of time in future. Eventual consistency means consistency requirement in NoSQL databases meeting at some point of time in future. Data coverage is eventually to a consistent state with no time frame specification for achieving that. ACID rules require consistency all along the processing on completion of each transaction. Base does not have that requirement and has the flexibility. This is the difference between relational and relational and no SQL transactions. So in case of transaction NoSQL databases, feature of NoSQL transactions can be defined now. NoSQL transaction have the following features. Relax one or more of the asset properties, characterized by two out of the three properties. Two are at least present in the application service or process, can be characterized by base property. Okay, we can also say it should be characterized by base property. Big NoSQL solutions use standalone server, master slave, or peer-to-peer distribution models. So two different points of view for relational database. Consistency is essential. Immediate after consistency. Immediate data consistency. For distributed system, NoSQL databases, Service availability is essential. Consistency may be relaxed as eventual data consistency or base transaction. Okay. So this was today's lecture.